So I'm going to go through and explain how to do number 1 from the 2011 AP Chemistry for response. Okay? So for number 1, it tells you have 3 different beakers. Each contains 25 milliliters of 0.1 molar solution of HCl, NH3, and NH4Cl. Okay? The first thing it tells you to do is determine the pH of the solution in beaker 1. Now, this is a really easy question because HCl is a strong acid, which means that you can assume that all of this is going to dissociate and then just take the negative log of that concentration because that will be your concentration of H+. Okay? So you just take the negative log of 0.1, you get 1.000, and if you wrote that, then you get 1 point. Now notice it's 1.000 because you have 3 significant figures, which means you need 3 decimal places. Okay? For question B, it says in beaker 2, so you have NH3, okay? This reaction occurs because it's a weak base, so this is a base dissociation reaction. It tells you the value of your Kb, and it says write the Kb expression, right? So not bad at all. Products over reactants, making sure not to include H2O because it is a pure liquid. In II, it says calculate the concentration of OH-. Okay? So here it doesn't show any of the work, so I like to show you where I got my work from, so I'm going to show you right here. So you've got 0.100 molar of your weak base. It's not going to dissociate completely because it's a weak base. So there are your equilibrium concentrations, XX 0.100 minus X. Then you can go back and see how they plugged all of that in, okay? So this is their way of showing their rule of 100. You show your rule of 100, how you get rid of X, okay? And then you can actually solve for X, and then your X value will be 1.3 times 10 to the negative third, which is your concentration of OH minus, because X is your concentration of OH minus. Okay? All right, for CI, it says in beaker 3, this reaction occurs, and that occurs because NH4 is an acid, because NH4Cl is your salt. Remember, NH4 plus came from a weak base, which means it's going to be acidic. Cl minus came from a strong acid, and so you're going to ignore the Cl. So NH4 is going to act as an acid, so it shows you this reaction here. NH4 donates a proton, a hydrogen ion, to create the hydronium. Okay. It says calculate the value of Ka for NH4+. Well, we know the value, the Kb value for NH3. They gave it to us here. It's 1.8 times 10 to the negative fifth, which means we can determine the Ka value very easily by simply dividing 10 to the negative 14th by your Kb value. That gives you your Ka, 5.6 times 10 to the negative 10th. Okay? So make sure that you're giving yourself points as you go along. All of these are 1 point except for here. You just got to show your correct setup. You get a point for that and then 1 point for your correct answer. Okay, so all worth 1 point. In II, it says the contents of beaker 2 are poured into beaker 3 and the resulting solution is stirred. Assume the volumes are additive. So that's their way of telling you, hey, be careful because your concentrations are going to change. Okay? So if you look, beaker 2 and beaker 3, I've got this weak base and this weak acid. So NH3 and NH4 are being combined together. So since you're combining a weak acid and a weak base, what you can do, and they don't actually show this here, but what you can do, there are 3 different ways of you doing this. The most easy for me, and the way that I would prefer to do it, is actually just using your Henderson-Hasselbalch equation. So here I know that since I have my weak base and my weak acid, I can just take the negative log of 5.6 times 10 to the negative 10th, add that to the concentration of the base over the concentration of the acid. Now notice they're not 0.1 anymore because when you take 25 mils of something with a 0.1 molar solution and add it to another 25 milliliters, you're actually going to have the concentration. So your pH here, notice it's equal to your pKa because you have equal amounts, you have a perfect buffer, so the pH is going to be 9.25. Or you could have done it this way. If you didn't recognize that you're supposed to just use the Henderson-Hasselbalch, you could have said, okay, I have NH4+. What is that going to produce? Well, it's going to produce NH3 and H+. So this is an acid dissociation. I plug in my concentrations, my 0.05, 0.05, and then you can solve it, and what you'll end up getting, again, once you eventually solve for X and then plug that in, you'll get 9.25. Or, since you have equal amounts of weak acid, weak base, or you could have a base dissociation reaction. NH3 plus H2O gives you NH4 plus OH minus. again, you're going to go through and solve, but here, because this is a base dissociation, you'll plug in your Kb value here instead. Okay? Again, you're still going to get the same answer, which is 9.25. Okay, so totally up to you how you want to do it. Keep in mind, when you have a buffer, you can either use your Henderson-Hasselbalch, or you can do an acid dissociation reaction, just showing the values that you have. So I have a weak acid and my weak base present. Or you can do a base dissociation. It doesn't matter what you do, you're going to get the same answer. I personally prefer Henderson-Hasselbalch, but it's up to you. So the answer is 9.25. So that's the answer that they got. They didn't really show much work, which I don't like, so that's why I just showed you everything. So 1 point for noting that the solution is a buffer, so noting that the concentration of NH3 is equal to the concentration of NH4+, which we did in our calculation itself, and then 1 point for getting the actual correct pH. All right, D, the contents of beaker 1 are poured into the solution made in part CII. So keep in mind beaker 1 is a strong acid, it's H+, and it's stirred. Assume that the volumes are additive. Is the resulting solution an effective buffer? So they don't show half as much as what I would show. So give me 1 sec, let me show you what I've put. So you've got your buffer, which is NH3 and NH4+. Okay? So since you're going to be adding 25 mils of 0.100 molar HCl to your 50 mil buffer, because remember this is the buffer from the previous problem, you got to figure out your new concentration. So I know the concentration of NH3 was 0.05. There are 50 mils of that, and then you're going to divide that by the total new volume, which is 75. So the answer that I get is 0.033 for the initial concentration of NH3. If I do the same thing for H+, okay, so 25 times 0.1 divided by the total volume, which is 75, you again get 0.033. It just happens to work out that way. And then NH4+ and NH3 are going to have the same concentration. I just did my math the exact same. I'm going to have these react because it's an acid and a base reacting. And so what I end up getting for NH4+ is it's 0.066 molar of NH4+. Now the question says, would the resulting solution be a good buffer? Well, since you don't have any of your weak base left over, you only have your weak acid left over, no, it's not going to be a good buffer because this weak acid, the only thing it can react with is a strong base that's added. If a strong acid were added, you'd be tough out of luck because an acid won't react with an acid. And so this would not be a good buffer. And then if you look for DII, it says calculate the final concentration of NH4+. That's what I did here. I got 0.066. So I'm going to go back really quickly and look over what they put. So note here, you get 1 point for the correct response with an acceptable justification. So here, note that noting that you only have NH4+ left over, that would suffice. Okay. Here, showing your calculations, you get 1 point for the correct calculation of NH4+, and then you get 1 point for the correct, for the correct number of moles of NH4+, and then 1 for the correct concentration. So 1 point earned for the correct calculation of the final volume and concentration. Now, you might say, well, I didn't show all of this work. That's fine. You don't have to show the moles. You can just show your new concentrations. By showing the new concentrations and that your work is correct, they'll know you got the right number of moles and the correct volume. So you'll get those 2 points. So don't freak out about that. Okay, so the hardest part for this question is just figuring out if you add H+, what will the H+ react with? And well, H+, since it's an acid, will only react with the NH3. If instead I had added OH-, OH- is a base, it would have reacted with the NH4+.